Hey there, this is Ari. Welcome back to the show. So the old way that people used to think about improving their energy levels was largely about drinking coffee, taking your caffeine, taking, energy pills and energy drinks that are usually filled with basically nothing more than caffeine or other stimulants and sugar. And the interesting part about that is that it actually does work to improve your energy levels, but only for a few hours. And then you actually pay a price for it. And especially if you use it on a daily basis, you pay a big, big price for it. And it's very insidious, that whole process of paying that price. And the reason why it's insidious is because those stimulants, whether it's caffeine or other stimulants, absolutely do give you an immediate or relatively immediate short-term boost in your energy levels for a few hours. So you, when you take those things, perceive them to be giving you a boost to your energy levels. But what you don't realize is going on is when you do that on a daily or near daily basis, your brain actually feels overstimulated, okay? And what I mean by that is the brain has a certain balance of various neurotransmitters that are either stimulating neurotransmitters or more calming inhibitory neurotransmitters. And it's constantly trying to maintain the appropriate balance for example, different parts of the day, whether you're waking or sleeping, for example, that neurotransmitter environment changes a lot. So the brain has a system to regulate the proper balance. What happens when you take stimulants like caffeine is you disturb that balance. You literally actually plug up the receptor for one of those calming inhibitory neurotransmitters called adenosine. And when you plug that up very frequently, the brain basically says, hey, I'm out of balance here. We have too much stimulation going on and not enough inhibition. So we need to establish better balance of those neurotransmitter systems. So what does it do? It basically makes more adenosine receptors, and it makes more adenosine to try to flood the brain with more calming, energy decreasing neurotransmitters. Okay. And then since you feel fatigued, what do? The next day, you take more caffeine, more coffee, more energy pills and stimulants. And then you notice that it gives you a boost. But again, this process of actually your brain making adaptations that lower your energy levels over time is actually what's happening in a subtle way in the long term, even while you are getting that short-term immediate boost. So what happens at the end of all of this is basically within a few weeks of doing that, your brain has already made adaptations to counterbalance that overstimulation. And as a result, it lowers your baseline energy levels and your baseline mood and cognitive function as well. And this is the reason why people who drink, multiple cups of coffee every day often wake up like a zombie, and they have a very difficult time getting out of bed. Their brain is not very functional when they first wake up. They got to get that stimulants. They have to get that caffeine in their system for their brain to turn on, for their energy to turn on. And again, that's the insidious thing that's going on is what they don't realize is that all of that daily consumption of caffeine and stimulants is actually what is lowering their energy levels in the first place. So all of this is to say that the old way that people used to look at how to improve their energy levels was really about coffee, caffeine, stimulants, energy pills, energy drinks, and so on, quote unquote, energy pills, energy drinks. And again, this is mainly just caffeine, stimulants, and sugar in these things. And the problem with them is, again, that they lower your energy levels over time. So that's the old way of doing things. What's the new way? Well, the new way of doing things is to understand that if you have low energy levels, it is ultimately a problem with your mitochondria not producing enough energy. Now, that can be for many, many reasons. There's many factors that can contribute to that. Psychological stress, emotional stress can contribute to that. Circadian rhythm disruption and sleep disruption can contribute to that. Toxins can contribute to that. Poor nutrition can contribute to that. Poor gut health can contribute to that. There's many, many different kinds of factors that can ultimately result in your mitochondria not producing enough energy. But ultimately, what the goal is, if your goal is to increase your energy levels, it is to switch your mitochondria back on, to build them bigger and stronger, to build more of them, something called mitochondrial biogenesis, to repair mitochondrial membranes, to provide the cofactors that mitochondria need to produce abundant energy. And all of those things is the new way to produce optimal energy. It's not about just pumping stimulants and sugar into your body and overstimulating your brain by disrupting the neurotransmitter balance or causing the release of stress hormones. It is about actually optimizing your own body's, your own cellular ability to produce energy at the mitochondrial level. And we have a formula called Energenesis that is the most powerful mitochondrial enhancing supplement on the market. And it is not about, providing an immediate boost of energy. You can take stimulants and caffeine to do that. This is about actually building up your mitochondria to produce more energy over the long term. So the difference is, while stimulants are actually lowering your baseline levels of energy over time, this formula, by building up your mitochondria, is actually building up your baseline levels of energy over time. So if you haven't already tried it, go to store.theenergyblueprint.com. Go grab yourself some Energenesis, try it out for 3 months. I think you're going to be blown away by the results. So with all that said, again, store.theenergyblueprint.com, grab yourself some Energenesis, and now let's get into the episode. Hey there, this is Ari. Welcome back to the Energy Blueprint podcast. I am very excited for today's guest. His name is Dr. Gil Blander. He is an internationally recognized expert in the biology of aging and for translating his discoveries into new ways of detecting and preventing age-related conditions. He received a PhD in biology from the Weizmann Institute of Science and completed his postdoctoral fellowship at MIT. He's been featured in the New York Times, Forbes, the Financial Times, and the Boston Globe. At Inside Tracker, that's the name of his business, he leads a team of experts in biology, computer science, and nutrition and exercise physiology. He founded the company in 2009 alongside top scientists from acclaimed universities in the fields of aging, genetics, and biometrics. Inside Tracker's mission is to help people realize their potential for long, healthy, productive lives by optimizing their bodies from the inside out. Their proprietary algorithm analyzes users' biomarker and physiomarker data to provide a clear picture of what's going on inside them. Based on their analysis, they offer users ultra-personalized, science-based recommendations for positive changes to their nutrition, supplementation, exercise, and lifestyle, along with a plan of action to track their progress towards their goals. Okay, so welcome, Dr. Blander. Such a pleasure to have you.
Thank you. It's great talking with you, Ari.
Yeah. So tell me the backstory here. How did you get involved in this particular field of the study of performance optimization, energy optimization, anti-aging, longevity? How did that happen? What's the backstory?
Yeah, so I'm a scientist in background, and as you can hear from my accent, I'm not a Native American. Was born and raised in Israel. From a very young age, I was fascinated by the aging process. I wanted to stop the clock. I wanted to live forever. I wanted to delay the onset of aging-related diseases. And that's why I studied biology. I got my PhD in biology from the Weizmann Institute of Science in Israel. And then I moved to MIT and spent 5 years at one of the best labs that's studying aging, the lab of Lenny Guarente. This lab found that SIR2 is a longevity gene. And during the time that I spent there, I realized that I can contribute more to humanity if I will start my own company than being a professor in the academia. So I decided to leave MIT after 5 years and spent a couple of years in a biopharmaceutical environment. And then started the company in 2009 with 2 other scientists. And the idea is to help people to live longer, better life based on what's happening inside their body. Basically, we are looking into your body by looking at the level of your blood biomarkers, DNA, activity tracker data, And based on that, we can understand your body and get a high definition view of your body. And then we can give you a set of recommendations. What should you do in order to optimize your body based on food, supplement, exercise, and lifestyle changes?
Got it. So when it comes to energy optimization, obviously there's tie-ins to various things like brain health, neurotransmitters, to sleep and circadian rhythm, to one's fitness levels, to one's body fat, and levels of inflammation have been tied to chronic fatigue. There's a number of potential factors that can relate to this. What do you think are the most important biomarkers that relate to human energy?
Yeah, so energy is definitely a very interesting and important part. And I think that fasting blood glucose and A1C are definitely a very important marker of the energy that you have. But there are some other markers that are related to that. For example, if you look at the level of iron that you have in your body, uh, as we know, iron builds the hemoglobin that is a very important part of the red blood cells, and it's carry the oxygen from the lung to the muscle to the brain. And if you don't have enough iron or enough hemoglobin, your energy level will decrease. Another marker that is related to that is vitamin B12 because it's important for building the red blood cells. So if you don't have enough B12, your energy level might be lower. So I think that there are a different kind of marker that can relate to that.
Okay, so let me throw a monkey wrench into all of this, which is several years ago, there was a paper published in the American Journal, the Journal of the American Family Physician. Okay. And it was evidence-based guidelines for physicians on how they should treat their patients with fatigue. And one of the key things they discussed in this paper was lab testing. And basically what they said is what they recommend for testing as far as people with fatigue is standard blood testing. However, they go on to say that only in 5% of cases of people with fatigue do they actually find anything of note, anything that's abnormal on those blood tests that could explain the fatigue. In other words, 95 out of 100 people who have fatigue, who get standard blood tests, get told, everything's within the normal range. So what would be your commentary on that? How could you do things differently than what the standard blood test would do with the typical conventional doctor?
Yeah, I think that the routine blood test needs a lot of blood biomarkers that are related to that. We discussed blood glucose, which is part of the routine testing. But for example, for iron, usually ferritin is not a marker that is routinely tested, and B12 is another marker that is not routinely tested. And when we are looking at our population, and we have a pretty high sample size, we can see that a high level of our users have a lower level of ferritin, which is basically a protein that use the iron and upload it into the hemoglobin. And especially in a young female, premenopausal women, and in athletic active people, especially runners, we can see a high prevalence of low ferritin. So it's much higher than 5% that you mentioned. Also, the B12 is another good example that it's not routinely checked, and because of that, they miss that. So I think that one issue is, first, they don't test the right markers, and second, they don't have time and the knowledge to look at preventative medicine. Our current healthcare system is more like working on whoever is broken, but they don't know how to treat the majority of the population that is healthy, but it can be better and optimized. So that's my answer for this question.
Gotcha. On the other, the benefit of standard blood testing is that most of those markers are extremely well validated, so that we know that if something's off, it's really meaningful. On the other end of the spectrum, we have a lot of the testing that goes on in functional medicine circles, much of which is not very well clinically validated. And I've seen numerous examples, for example, the food intolerance tests as just one example, that really most of the science indicates that they're not valid at all and that they don't work. On that spectrum of, standard blood tests kind of being, those markers being the gold standard, and, a lot of the stuff that goes on in functional medicine circles being not validated at all, where would you, how would you position what you're doing on that kind of spectrum?
Yeah, we are trying to use only tests that have been very well validated. So we are definitely using the physician grade test. What we are doing, we are bringing the right test for the right people. So as you mentioned before, the panel that they use to test is a routine blood test that missed some of the markers, but those markers are tested by physician if they needed to. Now, if you look at the functional medicine, and you mentioned food sensitivity, so we researched that and realized that food sensitivity doesn't have a lot of merit and a lot of science. There is a merit and science in the food allergy, but not in the food sensitivity. And a lot of people are doing it, and there are a lot of companies that selling it. And we decided not to do it because we don't think that there is a value there. So we are trying to test only markers that have been shown in the scientific literature to be relevant for our population, basically healthy population. Marker that you can also modulate by natural intervention, food supplement, exercise, and lifestyle changes. So if we cannot modulate it, we don't want to test it. And marker that at least 1% of the population is out of the normal. So if everyone is the normal, we won't test it because the value for the user is minimal.
Excellent. Okay, so is there any recent research in these fields that you're working on related to longevity or energy or sleep, brain health, anything like that that you feel is worth bringing up to discuss here?
Yeah, I think that first we done a research and published it a couple of years ago. And what we done, we looked at a population of around 1,000 subjects, our subject that have been tested at baseline and at follow-up. And the follow-up was around 7 months post baseline. And between that, they follow insert tracker recommendations. So basically, they got tested. Based on that, they chose a goal. Based on the goal, we gave them recommendation. And then they followed the recommendation on average for 7 months. And what we have seen also that this cohort of 1,000 users selected around 500 different recommendations. So it's a very personalized plan because only on average 2 people selected the same recommendation. And then we looked at the effect of those recommendations on the biomarkers from baseline to follow-up. And what we found is a significant improvement of those biomarkers in a subpopulation that started with high glucose or high cholesterol or high inflammation or low vitamin D or low vitamin B12 or low iron. So we've seen a very nice correlation between using the insert tracker recommendation and improving the blood biomarkers. So I think that that's a very exciting because that say that personalized nutrition is working because the majority of them, as I said, selected a different recommendation, but those recommendations were very personalized for this person. And at the end of the day, when we combine all of them together, we've seen a population-based improvement of those biomarkers from baseline to follow-up.
Gotcha. So how do genetics play into this? And I'll say, for context, a couple of things. I've seen different software out there and claims being made about, if you upload your genetics to this particular software, it can tell you all these things about your health and your predisposition for this and that disease. It can give you practical recommendations on how to improve your health. And when I've actually explored, the actual evidence that some of those recommendations are being based on, it is often extremely weak evidence. And I've also talked to eminent epidemiologist, Dr. Tim Spector, who you might be familiar with.
Yeah, of course.
Who has done a lot of work around genetics and personalized nutrition. And he has also kind of agreed with me that a lot of those softwares that are out there are generally kind of junk science and are not very good. But I'm curious what your take is on, kind of the role of genetics in health, more broadly, health, longevity, disease, and obviously understanding that's a very broad question. Maybe you can sort of quantify how much you think it's a factor, and to what extent you feel that those kinds of genetic testing, how that plays into what you're doing, and how much of a factor is it?
Yeah. So first, genetic is very important for disease, especially for disease like cancer. So if you know the mutation that you have in that cancer, it can allow us to direct the right personalized medicine, the right drug for the cancer. So there it's playing a very important role. There are also other diseases, some cardiovascular diseases and other that genetic is very important to fit the right drug for the right person. In wellness, uh, in high level, genetic is playing a pretty small role. And I completely agree with Tim Spector, because genetics just show that you have a risk for a specific condition. For example, you have a risk for high glucose or risk for high cholesterol. That doesn't mean that you have currently a high glucose or high cholesterol. So it's not enough to do just genetic. You need to combine genetic with blood, and that's what we are doing. Now, if you will ask me, what is the percent, what are the percent that genetic explains? So if we look at everyone that have high cholesterol, what are the percentage of them that the genetic explain the reason that they have high cholesterol? I would say that it's pretty small. It's maybe 5 to 10%. But what we are doing with that is basically combining the genetic with the blood. So for example, you have a predisposition to high glucose, then we are looking at your blood and saying, do you have high glucose right now or no? Do you have low optimal glucose or no? And then based on that, we are giving you the information. We also, based on that, recommending to you the right recommendation and allowing you to enjoy the value of the genetic in combination of blood. But having the genetic alone doesn't give you a lot of value. And I agree with Tim that having something like that is not the best scientific approach to for your wellness and longevity.
Yeah. Are you familiar with Dr. Robert Naviaux?
No.
So he's a researcher at UCSD. He runs a lab for mitochondrial medicine there. He's done a lot of seminal research around chronic fatigue syndrome and autism in particular, and mitochondria, in particular, something called the cell danger response, which has been a very influential paper. But he's involved in something you're probably familiar with, which is metabolomics research. And so, for example, he did a metabolomic study on people with chronic fatigue syndrome, where they went, way beyond the typical standard blood panel of whatever 30 or 40 biomarkers, and they tested over 600 different metabolites in the blood, and they found widespread dysfunction. They found that there was a downregulation in about 80% of the overall biomarkers that they tested in people with chronic fatigue syndrome. I'm curious what your thoughts are on metabolomics research. My understanding is that's kind of an emerging, really important field related to what you're doing. And also, are there any other emerging sort of lines of evidence that are really compelling as it relates to energy or longevity?
Yeah. So I think that metabolomic is an interesting and exciting field. There are a few companies that allow you to look at a lot of metabolite at once, and the technology becoming better and better. So I think that it's very interesting to follow it. I think that the challenge with currently with metabolomic, that as you said, 40% of them went down, but then not all of them are known and the function of them known. And also, then what can you do with that? What can you do with the data?
Yeah.
Because how can we modulate it in order to bring it to the right level and improve the chronic fatigue, as you said. So I think that metabolomic for me is very similar to microbiome, that it's interesting, it's exciting, but it's not actionable yet. And it's very hard to get the action reaction today. I think that it might be in a few years, but it's not ready for the prime time for users because the question of so what? Okay, I know that those market went down, but what can I do with that? And I don't think that we are there yet.
Let me before we go on to the next one, I'd like to follow up on that with another question.
Sure.
So, and I'm trying to formulate these thoughts on the fly here. Let's say that if you can do some kind of comprehensive testing that tests for, let's just say it was possible to test for every different metabolite that's known or testable in the human body.
Yeah.
And in an ill person, you find, like Dr. Robert Naviaux found, this sort of widespread dysfunction in, 50%, 60, 80% of all these different hundreds of metabolites that you tested for. But then to bring in your perspective, you're saying, yeah, but 90% of what you just tested for, we don't even know what those things are or what they do. We don't know how to modulate them. Well, so I would ask you, if that's the case, if you're only looking at the little sliver of the picture that that we know what those biomarkers are and what they do, is it not the case that you're just looking at, a very small picture, a very small, slice of the overall picture of what's going on?
Yeah, I'm not saying that we shouldn't do that.
Okay.
What I'm saying that the value for the end consumer is limited. So yeah. I'm not saying that you should do that. I think that it's a great work for or something that the academia should do, the NIH should do, and try to understand what does it mean. And when it's ready, then a company like us should offer it for a consumer. But just to give a consumer data from metabolome and showing that there are 50 small molecules that change their expression or their level, I'm not sure what is the value for the end consumer. That's what I'm saying. I'm not saying that it's wrong for the academia should do that, the NIH should fund it, the DARPA should use it, and we need to come with a pharmaceutical company should do an experiment with them. But I'm not sure that today to have it in a product and ask the consumer to pay hundreds or thousands of dollars for that, what is the value for the consumer? That's my question.
Got it. Yeah, and on the one hand, I agree with you, but I think here's where I think this is relevant. I think there are different paradigms of ways that people approach human health optimization or fixing disease. We have a sort of conventional medical model that whenever there's someone ill with something, they're searching for, this is a bit of an oversimplification, but they're searching for the one biomarker, the one thing that's quote unquote the cause of this. So if it's depression, it's, low serotonin levels in the brain. And so then we create a drug that fixes the quote unquote cause of depression by, with specific serotonin reuptake inhibitor drugs, antidepressants. Or cholesterol is the cause of heart disease, and so we give statin drugs. So let's say you have an ill person and they've got high levels of inflammation, they've got high levels of, they've got metabolic syndrome, they've got high levels of blood, they've got high blood pressure, they've got insulin resistance, high levels of blood sugar, they've got high cholesterol levels, high LDL, and so on, high triglycerides. They've got, high levels of CRP. They've got, on and on and on. You list 20 different abnormalities that person might have. the conventional medical model might look at that person and say, okay, well, we've got, all these different markers. We know this one's off, we know this one's off, and this one's off. So let's give you antidepressants, and let's put you on statin drugs, and let's give you blood pressure medication, and let's give you metformin for your blood sugar. That's the kind of thinking of the conventional medical model. On the other hand, you have, people in the natural health community who might look at natural interventions. Let's use exercise as an example. Exercise might affect and does affect dozens of different systems in the body and probably hundreds of different metabolites throughout the body, and has effects on the brain and the heart and the arteries and the liver and the gut and so on and so forth. So there's kind of two different, like fundamentally different ways of thinking about how you approach widespread systemic dysfunction. Do you try to identify each of the biomarkers that's off and modulate that specific one with some kind of specific drug or other intervention? Or do you look at the whole system and think, how can I optimize this entire system?
Yeah, so we are using the ladder. Basically, we are looking at all the biomarkers together and trying to find if there is one solution, like you said, exercise might be the one, or doing meditation, or I don't know, changing, losing weight is another one that, and we are trying to find what are the best recommendations that cover the most of the issues that you have. But what so that's our approach, but in a way we are using the conventional medicine in a way that we still use them based on the peer-reviewed scientific publication. And believe it or not, there are a lot of peer-reviewed scientific publications that look at exercise and weight loss and meditation and other. So we are trying to look at, to use the holistic approach, if possible, but still we want to give you the value of, like the value that you receive from your physician, but instead of subscribing to the drug, we are recommending you food, supplement, exercise, and lifestyle changes.
Excellent. So what does this look like, sort of on a practical level? If somebody wanted to work with you, what would they need to approach you with? What kind of tests would you have done? And what would the process look like of working with them?
Yeah, so the way to reach us is basically come to insertracker.com, and we have a few offerings there. You can either bring your own blood data if you've done a test with a physician and upload it into our platform, and we'll basically extract the data from a piece of paper using an application that's called OCR. We can, if you don't have data, we can help you to get the data. So we can send you a kit to your house, and you can prick your finger, a few drops of blood, and send it to us. If you don't want to do that, you can go to a lab. We have a partnership with Quest Diagnostic, which have around 1,500 clinics around the US, and you can test there. If you don't want to go to the lab, we can send a technician to your home or office, and the technician can take the blood and send it to Quest. So that's about the blood. DNA is similar.
Quick question. So the kit that's just a finger prick kit with a few drops of blood,
yes.
Is that more limited in what you can, the data that you can get from that compared to drawing, vials of blood?
Yeah, it's much more limited, and the reason for that is we spend a lot of time on finding the right kit, and we really like that the data, the value of the data will be as high as the value of the data from when you go to the lab like Quest Diagnostic. So because of that, we found that only some of the biomarker get to that level. So yeah, it's limited. It's more limited than what you can do in the lab. For DNA, we have a few options. If you have data you've done the test with 23andMe or Ancestry, you can upload the data. If you haven't, we have our own kit, and you can basically we can send you the kit. You can we can collect some of your swabs collection, and send it to us, and we'll analyze your DNA. And we also integrated with some activity trackers, so Fitbit and Garmin, are already connected to InstaTracker. So if you have Fitbit or Garmin, you can connect it. We are working now on Apple Watch, so soon we'll have Apple Watch. So we are trying to bring as much data as possible. And then when you have all the data, we can build a plan for you based on your blood and DNA and activity tracker. We find what biomarkers, what DNA score, what physio markers are not optimized. You can select a goal out of 15 goals that you have. You can choose overall health, or you can choose lose fat, or you can choose distress, or you can choose improve performance. And based on that, we are selecting the right biomarkers, building a plan for you. You can select from the plan what intervention you would like to do. Then you follow the plan, and we have a way for you to check in. Because we have the activity tracker, some of the recommendation can be automatically check-in based on the activity tracker. So if you ask you to exercise, we know if you exercise, we know if you've done endurance or strength, or if you slept, we know that you slept. So we are trying to give you the highest value as possible. And then you should test again after 3 to 12 months. And we've seen in a lot of our users that the biomarkers significantly improve.
Excellent. Let me ask you, what would be the critical differences between if I just went, let's say, to life extension,
Yeah.
As I've done in the past, and ordered, comprehensive male blood panels, or, obviously people ordering the equivalent of whatever they're trying to order, comprehensive female for my wife, and getting those blood test results, which go considerably beyond, standard blood tests that you get from the doctor. What would be the difference between doing that versus what you're doing? Why should I do why should I switch from life extension and sign up with you?
So first, you don't need to switch from life extension. You can continue to do life extension and take the data and upload to InstaTracker. So I don't want to make money on your blood test. So I'm doing it because it's a service. But we start when life extension and the other are ending. Basically, they are showing you the data. As much as I know of life extension, you get the PDF file, which is look very similar to Quest or LabCorp, or the data that you receive from the physician, that's it. And then you need to understand what is ALT and what is SHBG and what is any other marker. We are taking that, we are explaining to you what is the marker, we are plotting it to you and showing you the progress over time. We are in those services, you get only the normal range. So basically, what is a physician decided as normal range. We develop also an optimal range. So based on your age and gender and ethnicity, we're showing to you whether you are normal, optimal, or out of normal. And then we are, based on that, we are giving you a holistic plan of how to improve all the biomarker that you have based on your goal and optimize yourself. So I think that InstaTracker start where life extension and the family physician and all the other companies are ended.
Excellent. Great explanation. Well, I'm very excited for this. I think you're offering a great service. I'd love to try it out myself. And maybe we can work out some kind of thing to help me recommend it to my audience. Maybe you can offer them a discount or something like that. I have one final question for you, which is, I'm very curious to hear, I mean, I would love for this almost to be its own hour-long conversation, but I'm very curious to hear if there's any unique insights that you've gathered in the realm of anti-aging and longevity. I'll give, I just saw about a week ago some new research out of Israel where they've identified CERT6 as a very unique controller of longevity. I'm curious to hear if you feel there are any particular biomarkers that are critically important, and maybe you can give, 1 or 2 or 3 tips of things that you found are the best ways to optimize for longevity.
Yeah, that's a great question and a great point. And actually, I've started a podcast, we call it Longevity by Design, that we are interviewing the smartest and the brightest professor in the academia about longevity. And we already recorded, I think, 5 episodes. And surprisingly or not, almost all of them were discussing 36. So it's definitely no coincidence that you mentioned that. And so I think that 36 is very interesting protein. By the way, when I worked at the lab of Lenny Guarente, I worked on 31 to 36. So basically, CRT is basically the homologous of the East CR2. And in human, you have 7 homolog of that, starting from 1 to running out to 7. And recently, 36 have been shown an interesting effect on longevity, at least on mice. So I think that 36 is definitely a very interesting candidate for longevity. I want to just to warn the audience that I haven't seen a lot of research in human yet, so be careful about that. It's encouraging, but there are not a lot of evidence that it's working in human. So as to specifically for longevities and a tip for longevity, and interesting information about longevity, there was an interesting paper that published, I think a week ago in Science, that a group, I think it's a group of Russian scientists that basically scanned the big databases like the UK Biobank, which have around 500,000 human. And they looked at they used the CBC, complete blood count markers, in order to see a correlation between longevity in a big population. And because, as you mentioned before, CBC is part of the routine marker that the physician tests, you can find it almost for everyone. And also compare it in another database in the US. And they use that to do some computational biology. And they found that based on that, they done some calculation and found what is the theoretical highest longevity that human can live. So yeah, so basically they found, based on this computational biology approach, that the limit of our longevity is between 130 to 150, which was interesting. Now, if you ask about new technologies about longevity, so there are a few exciting technologies, stem cells, CRISPR, and other that maybe will allow us, if you think about it, to replace our kidney when we have a kidney disease, or to replace our liver when we have a liver disease. CRISPR will allow us, hopefully, to cure diseases, because at least in one disease, sickle cell anemia, there was research that showed that you can use CRISPR to convert the mutation and basically cure those patients. So I think that there are a few very exciting technology that theoretically will allow us to increase our longevity. I think that today the best intervention is lifestyle. Change your lifestyle or improve your lifestyle, and that's what we are trying to do at Insert Tracker. Try to eat the right food for you, try to do the right exercise, try to sleep enough, and try to basically take the right supplement. Don't take too much. We see that a lot of people taking too much supplement, but take the right supplement based on what's happening inside your body. So if you'll ask me what are my recommendations for your audience is try to eat the right food, try to exercise the right amount, don't exercise too much, try to sleep well, and try to take the right supplement, and don't overload yourself with supplement. We have seen that a lot of the population in the US taking too many supplements, and most of them they don't need to take. So that is my recommendation in a nutshell.
Excellent. Dr. Blander, this has been awesome. Thank you so much for your time. Where can people learn more about Insight Tracker or sign up for it?
Yeah, so you can come to insighttracker.com, and that's our website, and you can have all the information there. And if you want to contact me, you can find me there in the About Us. You can also find me on LinkedIn, on Twitter, on Instagram, and so on. So wherever you want to find me, I'm there, and I will be more than happy to talk with you.
Excellent. Well, I'm looking forward to trying it out myself. And thank you so much for coming on and sharing your knowledge with my audience. And thank you for the work you're doing. I really appreciate it, and I find it very exciting.
Thank you so much, Ari.
Hey there, this is Ari again. Thank you so much for listening to this episode. I hope you enjoyed it. If you did, if you found it valuable, please share it with your friends, share it with your family, help me get the word out there. Also, if you're on YouTube, make sure to hit the subscribe button and hit that little bell to get notifications every time we release a new video or new episode of the podcast. And if you're listening to this, make sure to subscribe to this podcast on iTunes or on your favorite podcast app. Thanks so much for supporting my work at the Energy Blueprint. I hope you enjoyed this episode. I will see you in the next one.